What have we got here? We've got lesson 12. All right, lesson 12 today. It's a lot of the same stuff as yesterday. Gathering information about a line. There's points, slopes, perpendicular, parallels, and writing this equation. And just being able to go through all three forms. So being able to go from standard to slope-intercept to point-slope. Backwards and forwards, upside down, sideways. Let's see what we got. Parallel, perpendicular. Right away, let's just say what it is. Parallel slopes. Same slopes. Perpendicular slopes. The opposite. Reciprocal, or flip as we call it. So, just start right there. Let's just get that out of the way. Okay. Back it up. Back it up. Okay, what's the question here? Write an equation for the line that is perpendicular to n. Okay, so we're going to get something that looks like this. Something like that. Goes through the point. Y-intercept is 0, 5. Okay, well, let's graph that line. First, let's just put that point on the line. Might as well. 0, 5. There's 0, 5 right there. And if we think about the slope of this thing, we have to actually take a look at the slope. It looks like if I use these 2 points right here, it's got a slope of -2 over, what was that, 5 to 0? 5, so -2/5. So that means our reciprocal slope is going to be positive 5/2. You can write that as 2.5 if you want. And then from there, we're looking at x's and y's. I'm just putting it in this point slope form because that's the easiest way to put it into. So let's see. The first one it's on the 0.05. So y is going to be just y. And x is going to be, sorry about that. Nope, it's going to be y minus 5. Got to keep my x's and y's straight. So this one will be the same thing, minus 5. And then x, because there's x is 0, you don't write plus 0. You really don't even need these parentheses. But since I've got them there, I'm going to just leave them. Okay, so that's question number 1. And then we want a parallel line that has the same slope. So that's parallel. Got to make sure that we recognize those words. Passes through the point 3, 1. Okay, so that one's even easier. So y minus 1, because it's y minus k, and those point coordinates are h and k, equals same slope. So that would be -2/5 as the original line, x minus 3. All right, so it's a lot of the same stuff. Just we're kind of putting it all together here now. That's really what's happening. And let's see, we're just coming back through another one. We're saying, okay, line L is represented by the equation. Okay, there's an equation where we can see a slope. And we can see a y-intercept, which we call B. We want to write the equation of the line that's perpendicular to that. And it goes through this point. Okay, so question number 1 really is just writing the equation. So it's y minus 4 equals, the slope is 2/3, so it's going to be -3/2. That's the reciprocal flip of that slope right there. I know I've kind of obliterated there, so let's just do that. Okay. And -3/2, so it's flips and it's opposite. Flip that switch. And then, where's my x? Okay, I'm going through the point x minus -6 or x plus 6. So let me just double check that. Perpendicular. Got to be careful with that word. That's it. Okay, so we're good so far. 1 for 1. All right. And we look at our equation, the line perpendicular to P, passing through this line. I just forgot line P. Let me rewrite line P for a moment. So let me go back and rewrite that one because I am going to need that. That was y minus 4 equals -3/2 x plus 6. Okay, now question number 2. An equation of a line perpendicular to that goes through this. Okay, I think I know what they're doing here. They're just making us go perpendicular twice. You might realize that you're rotating 90 degrees and then another 90 degrees. That line's going to be parallel again. So for number 2, let's just do it. Y plus 2, because it goes through -2. And this slope comes down here, and it flips and switches. So it's positive 2/3 again. And it's x plus, -3. Yep, there we go. Okay. So what about lines L and N? Well, L and N are parallel. P is the one that's perpendicular in the middle. All right, rewind if you need to, pause if you need to, check it out. We're going to keep going here. In summary, oh boy, you can rotate all kinds of things, but when you do a double rotation, here's the big point here. You know, when you do a perpendicular and then another perpendicular, you end up parallel again to the original line. That's kind of how it works. So you start with a line, let's just say it's line L. You make a perpendicular line, then you make another perpendicular line, you end up right back where you started. That is really the big deal. But other than that, everything else that's going on here is the same. The formula is the same. The y minus h equals m times x minus k. We're still using point slope right now. That's all we've had to use here. So if you don't have to convert, don't convert. There's just no point in it. Let's take a look at some of the homework. Little bitty homework. Here we go. The right color pen. There we go. There's an equation on a graph. You know, looks like there's a point there that hits, and looks like there's a point there, so I can get the slope off of that graph pretty quickly by just doing slope triangles real fast. And I can say that slope is positive, and it goes up by 1, and it goes across from 1 to 5 is 1/5. So it's a slope of positive 1/5. And that's x plus 1. That's slope intercept. Point slope would be, I can use this point over here, these coordinates. I can use those. Those coordinates are 5, 2. So it takes it 5 places to the right just to go up 1. Okay, so let's see. That means that I would probably be saying that that's just y minus 2 equals 1/5. The slope is the same. X, oops, yeah, that's right. 2 is the y. 5 is the x. X minus 5. Okay, let's see which one it looks like. Well, 1/5 x plus 1. The 1/5, this is where we got to start playing around. This is where the algebra comes in. You start playing around with this thing. 1/5 is actually 0.2. 1/5, 2/10. Same thing. So I see the point. That's minus 2. So it doesn't look like, yeah, 2's out. 1's out. Let me read the line. Let me read the question again. For each equations, graph of the equation, parallel, perpendicular, or neither. Okay. Oh, so I'm just looking for parallel, perpendicular, neither. So I got to be careful with your directions, folks. If you don't read them, you get lost. So let's see. If that slope is 1/5 positive, that means the perpendicular slope over here. Perpendicular slope is going to be 1/5. That's going to be 5. That's going to be negative. Okay. So let's see. 0.2 is neither. No, 0.2. That's it. That's 1. That's parallel right there. Negative 2 is neither. 5, that's got to be negative, so that's going to be a neither. Negative 5 here would be perpendicular on number 4. So I got a parallel here. I got neither, perpendicular here. Number 5 has got a slope of 2, so that's going to be a neither. And last one, this last one is just really, it's really y minus 5x, oops, y equals negative 5x plus 3, if I convert it into points or slope intercept. So minus 5x, that means that is a perpendicular one. So there you have it. Might have to do a little work converting around the edge of these, but it's all really related to Mr. M over here, slope. So somehow you got to see the slope in these things. So you may have to go back and forth from standard to slope intercept to point slope. Point slope and slope intercept are nice. They both show the slope. Standard, you got to kind of tweak it a little bit. All right, let's see what else we got on the menu. On the menu today, all equations. This time I'm going to read the directions first. Watch this. I'm just like you guys. I just start doing the work without reading directions. You ought to see me build things. Okay, select all equations whose graphs or lines perpendicular. Only one problem. I don't see the slope here, so I got to tweak this equation. I got to subtract 3x. So minus positive 2y equals minus 3x plus 6. Divide everything by 2, so you get y equals minus 3 halves x plus 3. 6 divided by 2 is 3. Okay, so that I have it in two forms. I don't have it in point slope form, but I don't really care because all I'm really concerned about is the slope right here. Okay, and I want perpendicular. So let's come on over to the other side. Ah, dang it, they gave me another one in the wrong way. So let's see. You might be able to do this mentally at this point and say that, you know what, y equals minus 3x plus 4, and just divide it by the negative 2. Divide by the negative 2. And that's going to give you that slope there. If that's going to be 3 halves, and we don't want 3 halves. This is our original slope. We want the perpendicular is going to be 2/3, and that's going to be positive. So that's really what we're looking for as we come on over to here. We're looking for that back over to the other side. So we've got to see if we can find those slopes. Okay, well, let's do this one right here in B. Y equals, subtract the 2x, we add the 6, and then we divide everything by the 3. So 3 and 3, and we're looking at the slope, not the y-intercept. So minus 2/3, no, it needs to be positive. So that's not going to work. God, they're really making us work for our money here. C, let's do C as well. We got to convert it. So we're just keeping that same thing going again. I'm subtracting the 2x. I got minus, well, let's just do this. Y equals minus 2x. Subtract that. I got the minus 3y. I'm going to leave that for a moment. And then the plus 8. And then everything gets divided by negative 3. So that means that right there, I can see right here that negative and negative, that's going to be a positive situation. So that's a slope of 2/3. That one works. So definitely C works. And then we go to D, and it's got a slope of 2/3. So yes, it works. And we go to C, and no, it doesn't work. And we go to F, and we say yes, it's got a slope of 2/3, and then G doesn't work. So those are all of our slopes that they're perpendicular to the original negative 3 halves, the positive 2/3. So you got to do the work. Got to do the work. It is required. Got to show the work. Okay, last but not least, all points, select all. I'm going to go do my same thing here. Select all points in the line with a slope of negative 1/2. So it has, no matter what, every single one has to have a slope of negative 1/2. The question is, this one goes through the point 4, negative 1, so it's going to be x minus 4 here, and y plus 1 on that side. Let's see, select all points in the line with a slope of negative 1/2 that go through 4, negative 1. So what we're doing is we're checking here. All we're doing is we're checking the x's and we're checking the y. So really what you're doing is you're coming in here, coming in hot. There's your x and y. You're just taking the 2. Great, 2 plus 1. Okay, that's 3. And then minus 1/2. For x, you're putting in negative 2. Negative 2 minus 4. So that would mean minus 1/2. Negative 2 minus 4 is negative 6. Half of that is 3. Negative 1/2 of that is positive 3. So that does work. So that means yes, that point is on that line. And with that, I think you're just doing the same thing for all the other ones. You're doing the same, you're just plugging in, you're subbing in right here all the x's and the y's. So you're just subbing in for y, subbing in for x. It's a sub situation, substitute that is. Substitute, and then you just evaluate. That means evaluate both sides of the equation. Okay, with that, we are going to say see ya on Thursday or Friday.